Hi everyone, my name is Dr. V. Sampath, Professor and Head of the Department Artificial Intelligence and Data Science. Today I want to discuss design and analysis of algorithm. In this, various design and analysis algorithms are available. Based on the problem nature, we have to select the algorithms. So today I want to discuss divide and conquer applications. In this divide and conquer application, we have to select the problem P into subproblem, sub-subproblem, and we have to solve the brief. In this one, problem may be P. In this one, problem may be P is the problem. P is the problem. We have to divide the problem into P1, P2, P3, and so on. Pk. In this one, problem may be complex or large. Complex or large problem. We are dividing the P problem into different P1, P2, P3 and Pk. In this one, then we have to solve this P1, P2, P3, Pk independently and parallelly. Independently and parallelly. In this one, for this one P1, we have to find the solution as S1. For P2, we will get the solution as S2. For P3, we get the solution as S3 up to Pk. Here, I am dividing the large problem P into various subproblems. P1, P2, P3 are the subproblems. I am dividing the problem, then I have to conquer. Conquer means you have to combine the solutions. Combine the solutions. Here P having different P1, P2, P3, Pk and S is the solution. Then again here we are adding all the solutions. Here S2 may not be dependent on S1, S3 may not be dependent on S2. The solutions may not be dependent with each other. Right? Next. For example, adding two numbers. For example, add any numbers. If I want to add 1 to 10, 1, 2, 3, 4, 5, up to 9. For this one, each operation it will take, for example, 1 second. 1 second. And if I divide this problem into, if I assign this problem to two persons, P1 and P2, I divided this problem to, I assigned this problem to two persons, P1 and P2. If 1 to 5 adding for one person and 6 to 9 add to the another person. Here it will take 4 seconds. 4 operations are there. It will take 4 seconds and it also takes 4 seconds. Then combining for this one, it will take P1 plus P2 4 plus 1 second. It will take totally 5 seconds. Previously it was 9 seconds. I reduced from 9 seconds to 5 seconds. So I reduced time complexity from 9 seconds to the 5 seconds. Now this is the divide and conquer. In this one, I want to explain merge sort. Different applications are there. Yeah. Divide the problem into two subproblems. Again, we are conquer means we are adding the subproblem, adding the solutions. Here divide the problem into number of Here divide means we are dividing the problem into number of sub-problems. These sub-problems are solved recursively. Right? Conquer means here the solution of the original problem, the form from the solutions to the sub-problems. We are finding the solutions. Now, problem is B here. Problem is P. P may be complex or large problem, and we are dividing the problem P into the sub-problems, and then we are finding the each solutions to the sub-problems. So, solutions are some. Then conquer. Conquer means combines all these solutions. Now, I want to discuss general method of divide and conquer. Here, first is algorithm divide and conquer. P is a problem. The problem may be large or complex. Large or complex. If first I have to check the given problem is small or not. If the problem is small, means returns SP. Means problem is small means the given element is only single element is there. Single element is there. This can say it is a small problem. Then divide P problem P into smaller instances P1, P2 and P3 up to k is greater than or equal to 1. K is greater than or equal to 1 means more than one problem. I am dividing P into different instances, different problems P1, P2 and Pk. Then apply divide and conquer to the P1, problem P2 and problem Pk to each of these problems. Then return combine. Combine nothing but solutions. We are adding the solution. Return combine divide and conquer P1, divide and conquer P2 and divide and conquer Pk. This is the general method for the divide and conquer. Next, applications. Various applications are there. In this one, binary search, merge sort, quick sort, Sarsen's matrix multiplication, Kasturba algorithms. These are the applications for the divide and conquer. Then advantage of the divide and conquer. Then it is advantage efficiency. It is better time complexity compared to the other quicksort, merge sort are the better time complexity compared to the previous sorting techniques. And parallelism. Parallelism means at a time parallelly we are solving the problem. I divided problem to the different person. I divided problem P to the P1, P2, P3, and at a time we can independently we are solving with each other. So we can say it as parallelism. Modularity. Modularity means we are dividing the breakdown complex problem into the different modules like P1, P2, P3, nothing but these are the different modules. Then scalability. Scalability is the real world applications. These algorithms perform well on large data sets and which makes them scalable real world applications involving big data. And reusability. Every module, we are dividing every module we are solving and we can reuse this module to the other projects or other problem solving technique also. Then this is a different, we can apply to the different reuse purpose we can apply. Reusability module we can reuse anyway, right? Next, now I want to take one, I want to discuss one application that is merge sort. Here, merge sort is one of the efficient sorting techniques algorithm. It is based on the divide and conquer strategy, right? And merge sort is continuously cuts down a list into multiple sublists until each has only one item. This means we are dividing problem P into the P1, P2, P3 and up to the problems to becomes individual problems like 1, 2, 3, 4, 5 like this. Up to individual problems we are splitting. For example, merge sort example is, for example, the given elements are 7 to 9, the given elements are 7, 2, 9, 4, 3, 8, 6, 1. Right? In this one, I have to divide the problem into two sub-problems. How I want to divide the problem into two sub-problems? Based on the mid. Mid is first number, last element position. then I have to find the mid. I will show next example practically by solving one problem. Then I am splitting the problem into the two sub problems. That is, this is the one sub problem. 7 2 9 4 3 8 6 1. These are the divided. Based on the bit, I divided the problem into the two sub problems. Now again, this is P 7 2 9 4 is the large one. Again, I divided 7 2 9 4 into the 2 7 comma 2 and 9 comma 4. Then again this is 7 comma 2. Again, two elements are there. Again, I have to divide this problem into the single elements. These are the individual solutions. 7 and 2. These are the individual solutions. For each problem, we are making it as individual solutions. We can say that 7 is one solution, 2 is one solution for this one, 9 is one solution and 4 is one solution. Again, this one, every elements will be individual element, individual solutions. These are the individual solutions. Then merge it. In this merge sort techniques, we use merge sort and merge procedures. Two procedures we have to use. Now, one more example, 11, 6, 3, 24, 46, 22 and 7. And again, I have to divide this problem into two sub-problems based on the mid. How many elements are there? 1, 2, 3, 4, 5, 6, 7. 7 elements are there. Means mid means 1 plus 7 by 2 is equal to 3.5. We can say 3 only. Right? 3 is 1 element and 4 is the 1 element. I divide this problem into again 11 and 6, 3 and 24. And again this I divided to the 46 and 22 and 7. Again up to single element, these are the individual solutions. Then I have to merge. For this individuals, how I have to merge? Compare first element to the second element, and which is the smaller one, then you have to add to the first element. 6 is the smaller one, and 11 and 3, 24, 3 is the smaller one, and 46, 22, 22 is the smaller one, then I have to add 46 merge, then 7 is the single element. I get 6, 11, 3 and 24. We assume that this is I, this is J. This is I, this is J. Then each time you have to compare 6 and 3. 6 and 3. Which is the smaller one? 3 is the smaller one. 3 is the smaller one. Insert into the auxiliary array. First 3. Then which element we inserted into the auxiliary array, you have to increase that value. Now J becomes J plus 1. J becomes J plus 1. Then again compare 11 and 24. 3 inserted. J will be increased here. And again 3 and 6. 6 is the smaller one. In 24 and 6 is the smaller one. Increase I as next position. And compare I and J. 11 and 24. Which is the smaller one? I is the smaller one. Again there is no place for this one. Then automatically what left sub-array we completed, automatically we can copy from the right sub-array to the remaining array. Like this also, then we have to merge same procedure, merge procedure we have to follow. For example, I used to take the elements are 2, 10, 9, 6, 5, 4. 2, 10, 9, 6, 5, 4. Two, 10, 9, 6, 5, 4. Here, how many elements are there? 1, 2, 3, 4, 5 and 6. 6 elements are there, right? Here, first I have to divide the problem into A1 to AN elements are there. I have to divide the problem into A1 to A n by 2 and A n by 2 to n by n. an by 2 plus 1 to an. An by 2 plus 1 to an. Here based on the mid is low plus high by 2. Low plus high by 2. This is the floor symbol. This is the floor symbol. What is the low value? 1 plus 6 by 2. 1 plus 6 by 2 is 7 by 2. 7 by 2 is 3.5. This is the floor means we can take 3 only. Now I am dividing the problem into two sub-problems like 1 to 3 is one sub-problem, 2, 10, 9 and 6, 5, 4 is one more sub-problem. Right? And again I divide the problem into P1 and P2. Now again I have 3 elements are there. 2, 10 and 9. Then again this is 1, 2, 3 elements are there. Again I have to find mid. Mid is 1 plus 3 by 2. 1 plus 3 by 2 is again 4 by 2 is equal to 2. And mid this means 2 to 10 is one sub problem and 9 is the one sub problem. Again I have to divide this 2 and 10 up to single element. 2, 10, 2, 10 and 9 is one sub problem. And for this one 6 and 5, 4 is one more sub problem. Right? And in this one, this is first element I, this is j. I have to take one auxiliary array. B is one auxiliary array. This is A, right? B is an auxiliary array. I have to compare each element with each other. I and j. Which is the smaller one? 2 is the smaller one compared to the 10. So I am copying 2 into the auxiliary array. B is the auxiliary array. Auxiliary array nothing but temporary array. Then there is no element to the next position of the I, and 2 automatically there is no position of the I increment, there is no position, then you can copy next value 10. Here 2, 10 is one solution and 9 is one solution. And again I have to take one more auxiliary array. This is first position, this is second position, I and j. Now I am taking one more auxiliary array, that is I and j. I am comparing I and j, which is smaller value? 2 is the smaller value, copy. And which number we are copying into the auxiliary array, we have to increase that value. Now I becomes 10. Now compare I and j. Which is the smaller value? 9 is the smaller value. Copy that value into the auxiliary array. Right? And again j. Increase the j's position. There is no other j's position. So whatever elements are available in left subarray, just simply copy into the auxiliary array. Similarly, we do same problems. Sub-problem 2, that is 6, 5, 4. First is 6, 5, 4, which is the smaller one? 5 is the smaller one, right? Then 6 is the bigger one. Then 4. Now 5, 6 is one solution and 4 is the one sub-problem. Again compare 5. Take auxiliary array, B is auxiliary array. Then I and j. Compare I with j. Which is smaller value? J is the smaller value. Copy into the auxiliary array. Then increase this one. There is no next position of the auxiliary array. Jth position. There is no jth positions are there. Simply you can copy whatever elements are available from left side, left sub problem. You can copy into the auxiliary array. Now the solution is 2, 9, 10 and is one array, one sub problem solution, and 4, 5, 6 is one sub problem solutions. Then we can add 2, 9. Then we can take one more. Then we have to merge it again. Two sub problems we have to merge it. 2, 9, 10 and 4, 5, 6. 2, 9, 10 is one sub problem. 4, 5, 6 is the one more sub problem. Now we have to merge again with the help of the auxiliary array. I have to take one auxiliary array. Then this is the ith position, this is the jth position. Now compare 2 and 4. 2 and 4, which is the smaller value? B is, this is the temporary auxiliary array, temporary array. 1, 2, 3, 5, 6. 6 elements are there. Compare I and j. Which is the smaller one? 2 is the smaller one, right? 2 is the smaller one. Copy 2 inside the auxiliary array. Then increase 2. Increase the ith position. Now I becomes 9. Compare 9 and 4. Which is the smaller one? 4 is the smaller one. Copy into the whatever element we are copying, increase that element position. Now j becomes 5. Compare 5 and 9. Which is the smaller one? 5 is the smaller one. Copy into the auxiliary array. Then again increase j. Now j becomes 6. 6 and 9. Which is the smaller one? 6 is the smaller one. Right? Now this side subproblems solutions are completely copied, means this is completely reached to the mid to the high position. Mid one to the high position. Then you have to copy whatever elements are available in subproblem into the auxiliary array. Then I can copy 9 and 10. This is one auxiliary array. Then again I have to copy the solution into the our actual array. That is 2, 4, 5, 6, 9 and 10. Right? I have to copy from auxiliary array to the original array. This is the solution of the merge sort. I will show one more example. This is one example. This is one example. Similarly, what we discussed just now. And merge sort algorithm. Now, merge sort is different and merge algorithm is different. Now, algorithm merge. Right. Algorithm merge low comma high. Low comma high means first is we have to take a low indexing value and high indexing value, right? And then if low is less than high, means the problem is small or not. We are checking here the problem is small or not. Then if low is less than high, means if it is low is less than equal to means single element only, right? If low is less than high means there are more than one elements are available in the given list, right? Mid is equal low plus high by 2. Low plus high by 2. Then merge sort low comma mid. We are finding low to mid, and this is low to mid and mid plus 1 to high. Mid plus 1 to high. Then merge sort mid plus 1 to high. Then merge procedure we follow low, mid and high. Low, mid and high. Next, algorithm for merge is now for merge we take low, mid and high. Low, mid and high. Low, mid and high position. Right? In this one, I am taking H as low, I as auxiliary array, and J is the mid plus 1 position. This is J is the mid plus 1 position, while H is less than or equal to mid and J is less than or equal to high. This means first we have to move low to the mid, and then we are taking J means mid plus 1 to high. Then if A of H is less than A of J, means first element in the first array, A of J, second element in the second array. Then if A of H is less than A of J, copy A of H into the auxiliary array, then increase auxiliary array position, H is equal to H plus 1. Right? Otherwise, if it is this condition is failed, then copy A of J into the B auxiliary array, B of 5. Then increase the J position, J plus 1. Then again, this is auxiliary array's position. I is equal to I plus 1 means auxiliary array. If H is greater than mid, then first subarray elements are completely copied into the auxiliary array. Then copy second array into the auxiliary array. This means for k is equal to j to high, do copy B of I, A of k, increase the I is equal to I plus 1. else. Else means second array completely copied. Means first array elements we have to copy into the auxiliary array. This is next. From auxiliary array I am copying to the original array. That is from I am copying auxiliary array into the A of k. Now I want to play one video on this merge sort. Now I have $1 lakh is there. I want to split this $1 lakh to the different persons. For example, I want to split this person amount to the like 25k, 50k, $50k, and $15,000, $10,000. Then I have divided this problem into the different two sub problems, two persons, and I have given this to the divided to the 4 persons. First person is $25, $50, and $10. Like this I split. Then I have to collect that amount from the 4 persons. I have to match it. Then I will get it as $1 lakh. This means we are dividing the problem to the sub problems, and again we are collecting means solutions. We are merging conquer here. Then we are getting the combining the solutions. Right? Next, for example, in a list 4 to 1 3 elements are there. Then I divided 4 to 1 3 as 2 elements, and then again splitting the sub problems single elements. Method means up to single elements we have to split it. Then compare each and every element 4 and 2, 1 and 3. In 4 and 2, 2 is the smaller one, and in this one 4 2 is one solution, 2 and 4 is one solution, and 1 and 3 is a one solution. Then again compare I and Z, 2 and 1, which is the smaller one, 1 is the smaller one. Then I will copy 1 into the auxiliary array. Then 2 is the, this is J, this is I1. Then again, which is the smaller one, I have to increase J to the next position. Next position, 1 is the smaller one, then J becomes next position. Now compare Jth element to the first element, which is the smaller one, 2 is the smaller one. Again increase the ith position to the next one. 4 and 3, which is the smaller one, 3 is the smaller one compared to that. Then 3 and 4, this is J completed. Again you can copy from ith position to the auxiliary. This is auxiliary array solution, and then I will copy into the next array. Whatever element, whatever array B, for example A. This is the A. We are copying from auxiliary to the. This is the 1, 2, 3, 4 is the solution.